Good day, class. You're welcome to our chemistry class for today. And in chemistry today, we shall be looking at application of the mole concepts. Under the application of the mole concepts, we shall be relating reacting mass to the product's mass, as well as the volume to another volume of solid, or looking at that of gas and a liquid. So let us take the first aspect, which is the mass calculations. And here's our question. We are to calculate the mass of calcium oxide formed when 1.5 gram of calcium is completely burnt in oxygen. So first is to have a balanced equation. Number one, calcium reacting with oxygen gas to form calcium oxide. And we need to balance our equation. So if we put 2 here and 2 here, that means we have 2 moles of calcium, solid, oxygen, and 2 moles of calcium oxide. Now from the reaction, we're told that 1.5 gram of calcium is completely burnt in oxygen. So we are looking for the mass of calcium oxide formed. Here, we need to calculate based on the relative atomic mass of calcium. So we have 40 grams of calcium. We need to calculate the relative molecular mass of calcium oxide. Calcium is 40 and oxygen is 16. So that is 40 plus 16, and that is 56 grams. Therefore, equals to 56 grams. But take note that we have 2 moles of each of them. Hence, we multiply each by 2. That will be 80 grams, gives us 112 grams of calcium oxide. Therefore, what will be the mass of calcium oxide if we have 1.5 grams of calcium? It will be equal to x gram. So x will equal to 1.5 times 112 over 80 grams. And that will give us 2.1 gram of calcium oxide. Example 2. Calculate the mass of sodium tetraoxosulfate 6 formed when 0.5 mole of sodium hydroxide reacts with tetraoxosulfate 6 acid. Now this is a neutralization reaction where we have sodium hydroxide plus H2SO4 to give salt and water. We need to check if the equation is balanced. Obviously it's not balanced. We have 2 atoms of sodium here. So if we add 2 here we have 2 of oxygen, 4, that's 6. We have 2 of hydrogen here. So if we put 2 here, we find out that our equation is balanced. We are relating the mass of this with sodium hydroxide. So let's take note that we have 2 moles of NaOH and we have 1 mole of Na2SO4. What is the mass of Na2SO4? We need to calculate the relative molecular mass of Na2SO4. We are told that sodium is 23, so we have 23 times 2 plus sodium is 32. Oxygen is 16 times 4. Here is 46 plus 32 plus 64. Therefore, the total will be 142 grams. So we know that we have 2 moles relating it to 142 grams of Na2SO4. Hence, if you have 0.5 mole of sodium hydroxide, how many grams of sodium tetraoxosulfate 6 are we going to have? That means we have 0.5 times 142 over 2 moles. That will give us our value, 35.5 grams of Na2SO4. Alright, example 3. Calculate the mass of lead 2 tetraoxosulfate 6 formed when 0.01 mole of tetraoxosulfate 6 acid react with lead 2 chloride. So first we need to get our equations right. PbCl2 reacting with H2SO4, it will produce PbSO4 plus hydrochloric acid. We need to check if our equation is balanced. From here it is not balanced because we have 2 atoms of hydrogen here and hydrogen is still 1 here. We put 2 here and now it's balanced because we have 2 of hydrogen here, chlorine is 2 and here it is also 2. So we are relating PbSO4, we are relating it with H2SO4. We have 1 mole of H2SO4 here and we have 1 mole of PbSO4. With that, we are aware that we have to calculate the relative molecular mass of PbSO4. We are told that lead is 207, sulfur is 32, and oxygen is 16 multiplied by 4. That's 207 plus 32 plus 64 grams, and that will give us 303 grams of PbSO4. So we are going to relate 1 mole of H2SO4 to 303 grams of lead 2 tetraoxosulfate 6. What will be the mass if we have a 0.01 mole of H2SO4? And that will be 303 times 0.01. That's equal to 3.03 grams of PbSO4.